Good morning, everybody. My today's topic is use of ICT framework for small scale tea farmers. I am Dr. Shadil Shaha, Associate Professor and Associate Dean, School of Engineering and Technology for Compliance, Kaziranga University. I welcome you all for this session. So I hope all of you are the tea management students, so you have the ideas regarding the tea management and tea plantation and everything. So my focus is on the what is the India status in global tea productions levels, and right now what is the futures of tea plantation in India, and tea ecosystems in India, and how to improve that ecosystems using ICT. As I am students of CSC, so I have very little idea about tea, but at the time of doing those projects, so I have to come through this part only. So first of all, let us check that what are the current scenario regarding the global productions of tea in India. So earlier, 30 years back, India was the first number one topped in tea productions. Right now, India becomes in second positions. China is the number one, having the total tea productions of 36%, followed by India having the tea productions of 23%, and the rest of the tea producing countries are Vietnam, Indonesia, Sri Lanka, Kenya. So they are producing. So how China has surpassed, that is only because of the implementation of ICT, and why India's tea production has declined just because of the environment change. Earlier, the northeast belt, Duars, and the Nilgiri belt, which are the main tea producing land for the India's, because the environment suits in those areas. Right now, this areas has environment has affected a little bit in those areas. What are the environmental effects that are basically directly related with the tea productions and yield? First is it the temperature, then moisture level, then pH content. Temperature means the ideal temperature for tea production is 17 to 23 degree centigrade. Now that is also again related with the rainfall also. So the average rainfall that is required for tea productions, that is a favorable situation, is 2000 to 4000 millimeter. Now in Assam, if we consider the Assam rainfall scenario, average rainfall during the monsoon season is 2000 to 4000, but that is not for the last few years it becomes an irregular one. So our monsoon, I am showing you the entire average rainfall statistics of entire northeast belt. That is the average rainfall. If you find out from the 1971 to 2015, that red line shows that whether it is if it is a straight line, and that case the rainfall is static. The rainfall conditions in all over the years, if we consider with respect to the previous years. Right now, if it is a declined or inclined, that means there is a downfall in rain or increase in rain. So the straight line is a little bit of declined one. So it shows that the average rainfall has decreased. Now look at the monsoon wise. So the second graph shows the winter rainfall statistics, that is the January to February. Third one is the March, April and May. Fourth one is the monsoon season, that is the June, July, August, September, and fifth one, and again for the that is the post monsoon. Actually it should be October, November, December, not the June, July, August, September. So first thing, it is clear that there is an average downfall in rain in the last 50 years. Second thing, that is also very much of concern, that is we have used the Mancandle test. After taking all the rainfall data, we have taken this data from the Regional Meteorological Center, Guwahati. So in Mankandal test it says that you have to compare through interpolation technique with respect to the previous year's rainfall data, and if you find out that the entire 50 years that comparison that falls below +2 or -2, that case there is a irregularity in rainfall. So the red mark shows that in those areas it has fall down between -2 and +2. So this is also clear that the rainfall is irregular. So if our rainfall becomes regular, whether it is a decline or the downfall in rainfall or increase in rainfall, that case also the situation can be tackled out. But if the rainfall is irregular, that case we have to take care of that scenario. Why? Because if there is an increase in rainfall, that may that can happen waterlogging in some of the surface level. Now surface level, if there is an waterlogged happens, that can be removed through different techniques. But if the waterlogged happens in the subsurface level, then very difficult to identify that one. Otherwise it will may cause it may affect the root of the tree. And again the increase in rainfall also becomes proportional with the temperature, because our average temperature, as I already told, that for favorability production is 23 degree 17 to 23 degree temperature, but during our monsoon season the temperature increases right now beyond 31 32. So that cases the photosynthesis of the tea leaf increases, and it reduces the quality of the tea, and the taste of the tea becomes decreases. And at the same time the pH level also makes an effect on the tea soil. So pH level should be within 4.4 to 5.5. So if there is a salinity in the soil, that case also it will make a causal effect. So the first thing is that we have to make a continuous monitoring of the temperature, moisture, pH level, humidity, as well as the salinity of the soil. And if the garden is spread across 100 acres or 300 acres, then it becomes very difficult to monitor the entire area of the tea soils and take appropriate actions. So our objective as a computer science scientist and is to how to make a remote monitoring systems using an ICT through which the temperature and moisture condition of the soil based on the variable weather condition, and so that we can take the appropriate farming practice such as tillage, seeding, fertilization, herbicide, pesticide applications, and to develop a garden level panel data sets and estimate the statistical model to identify the causal effect. What are the main causal effect of the monthly temperature, moisture content of the soil, pH level of the moisture, and drought intensity on the yield of tea production, so that appropriate measures can be taken care of. Now at the time of setting up this remote monitoring systems, we faced two problems which will be discussed which is discussed in these two areas, that I will discuss at the time of showing you the entire setup. Now the remote monitoring system is built on the Internet of Things. I hope you know what is IoT is. Internet of Things is basically the internetworking of physical devices. Earlier we used to connect the devices like mobile, laptop, iPad, tab, etc. through internet. Right now we have the ability to connect any physical devices through internet, and if that physical devices has the capability to sense the temperature, moisture, humidity, that case it says the Internet of Things. Now our main job is to connecting the entire ecosystems that is related to agriculture, that makes a causal effect of tea farming specifically through the internet, so that they can give you the data to your mobile from the remote locations without any human to human or human to computer interactions. Now this is our systems overview. As you have seen that the entire tea gardens we are planting the different we are planting different nodes. So one node is the temperature sensor, the blue one is the soil moisture sensor, and the gray one is the pH level pH content sensor. So we are placing in a strategically located places to the entire tea gardens. Now the temperature sensors will send the data among themselves, and the collected data will be sent to the local server, and local server will send to the cloud server. We have created one cloud where the entire data will be collected, and that data center may be in India, maybe in somewhere else, nobody knows. Now this cloud data servers have one IP address. So through this IP address we can access those data and monitor the data content from any mobile, for any basic mobile phone having the smartphone capability. Now the setting up is done, and the data transmission is it's okay from the team. Some few issues we have faced. Now the main problem we are facing is the drainage of the power of the battery of each of the nodes due to the huge power consumption, because all the nodes are sending data to the local servers, but it is not required. I'm telling you, because if all the nodes are sending the data with among themselves through an network to a particular node, and that particular node will act as the cluster head. For suppose the how many temperature sensors are we have established over there? 6. Instead of 6, it may be 600 also. So out of 600 nodes, one of them will act as the cluster head, and he will collect the temperature data of the strategically located places collectively to its vicinity, and then he will send the data to the local server. So in that case we can save the battery power of the rest of the 599 nodes. Now we have to sacrifice the battery power of the cluster heads, right? Now after few hours or few weeks, if I find out that the battery level of that particular cluster head gets drained down, so we will replace the battery, and at the same time we will change the cluster head of the other nodes also. So in this way, in an adaptive manner, the cluster head will get changed, so that any one of them will be the cluster head one by one, and he will collect the data from the other nodes, and then automatically and periodically it will send the data to the local server, and local server will send the data to the cloud server, and cloud server will send the data to the remote user. Now how to select the cluster head? It is not like that the human intervention is required. As I told, that it will be done entirely remotely from the remote site. So for the cluster head selections, we have implemented one algorithm, Clemens clustering algorithm, so that it will first create one cluster. So for the green nodes, they have created one cluster. For the blue nodes, they have created another cluster. You may have seen that. And for the violet nodes also, another cluster is created. And out of this, they have chosen any one of them as the cluster head. Now the other nodes will send their collected data. That may be the temperature, that may be the humidity, that may be that is the moisture content, or that may be the pH level to the cluster head, and now cluster head will send the data to the local server. The first problem is solved. Now the second problem, that is also one important problem, that is the whatever data is coming out of this, we find out that some of the data are the duplicate data, some of the data are spurious data, 50% data are irrelevant data. So we have to if we give the entire data to the farmers will get confused. So another problem, to solve out one problem, another problem comes out, and farmer will throw their applications that भाई मुझे ये application नहीं चाहिए. So what is the solution? Solution is that as we have sent the data to the server, so we can access the server data, that is the unfiltered data. Now through the data analysis technique, we will analyze the data and streamline those data. So main job is to whatever data has come out, so we will streamline those data through a tool that is called ETL tool, and we will remove the spurious data and take only the relevant data. So this is the entire process. These are the different sources from where we have taken the data, and it send it to the ETL server, that is is the extract, transform and load server. Will transform the data and load it to the data warehouse server. From that data warehouse server, which contains the filtered relevant data, and that will be sent to the farmers so that they can take the decision one by one. Now this is our entire sensor node setup. This part is not required, this part is not there, and I am telling you the entire setup we can put it into 3" by 3" Tupperware box, and that is an airtight one. And this is the this is the sensors which will be put it down the 1 feet or 2 feet deep of the tea plant, and this is the node MCU. Node MCU is a microcontroller. It basically its main job is to take the data and convert it to a to D controller, and then send the data through a transmitter. This one is the transmitter, this one is the receiver, and through this transmitter it will send the data to the local server. So basic job is to, there are one temperature sensor is there, there is one pH sensor is there, and there is one soil moisture sensor is there, and they are collecting the data and they are transmitting the data to the local server through this setup. And this is the entire diagram where you can find out that the node NC is connected with the soil temperature sensor, soil moisture sensor, and humidity sensors. And this relay pump portion is not required. Actually, initially we thought of that if the moisture level content is too low, that case automatically the pump will start. But later on we find out that the pump can pump is not required. Rather, spraying of water will be much more useful. So we remove that portion. So this portion is a part of this box, and it is connected, and the server is connected with an Arduino apps. That is because we have to give one user interface. So the farmer doesn't know what is Arduino, farmer doesn't know what is sensor, nothing. They need only the informations, and that informations will come to the Blink app that is available to all that will be available to all the farmers, and that will be available in your mobile also. And this is your actual board, and in that board we have installed that node MCU, and that node MCU is connected with this soil moisture sensor, and one temperature sensor is connected here, and one humidity sensor is there. And already told that this pump portion is not required. Only portion that we set up in a breadboard, this one. And this is the user interface that you will see in your mobile, that what is the temperature, what is the humidity, where is the soil temperature, where is the soil humidity. So in this way it will give you the values after every 5 seconds, and you can change it. If instead of 5 seconds, if you need after every 1 hour, if you need after 1 day, or if you need in every 1 week, that can also be given. And if you want the live data also, you can get it. If you so a period after a certain period, the period you will choose that after what period you want this data. Now another change also you faced, that whenever you are sending 100 packets, the nodes are sending, out of this 20 packets are being received. So why it is so? That is because of the conventional protocol, TCPIP protocol that we are using. TCPIP protocol we are using in case of our mobile transmissions also, that the way we are talking through IPv4 phone, the same protocols will not be applicable in the tea garden area. Why? Because in that case that requires huge bandwidth, and we have the bandwidth, we have the LTE connections, 4G connections, but how can we expect a 4G connectivity in tea gardens in a remote area? Not only that, the 4G there is no SIM, so there is no question of giving you the 4G connectivity. So only they will send the data through Wi-Fi direct connectivity only, and from the node that is connected with the node MCU, that will only have that connected the local, sorry, not the node MCU, the local server have only should have the connectivity of 4G. So that will transmit the data to the server. So this portion we can use the TCP IP connectivity, but in case of For your node transmission of data, we cannot rely on TCPIP. In that case, my throughput will be drop down. So throughput means the number of packets you are sending, the number of packets you are receiving by the number of packets you are sending. It's an average. So your throughput must be more than 80%, otherwise there is no use of this entire setup. So instead of TCP/IP, we have changed. We have used another protocol that is called MQTT protocol. In case of MQTT protocol, which requires low bandwidth and low latency and low delay, and we find out that after implementing MQTT protocol, the throughput increases more than 80%. So this is the basic structure of the MQTT protocol. This is not required for you right this moment. So this is our entire setup. I will show you one video. From that video you will be see the will have an idea that how the entire setup has been done. So apart, we have used these sensors only, ECH20 to take the volumetric water content and the measurement. And another thing is that this one is giving us the moisture level in terms of the percentage level. So if you in terms of the numeric value level, if you want that case, you can change your sensors also. So I request you to go through all types of sensors. There are several sensors are there. So this one is the most sophisticated sensors where we will get the weather, including the rain monitoring, sprinkling of water, medicine, etc. And it's it works from the 2 degrees centigrade to 25 degrees centigrade also, but and it is a little bit inexpensive also, but it is not available in Amazon, because we have to rely on Amazon only in this place. But as you are living in a metropolitan area, so you can have this sensors. Now another is the Pogo portable soil sensors. It is the best sophisticated one that is is now been used in the most part of France and Netherlands. But it is little bit costly, $950, more than 70,000. So if you can afford for the precision agriculture purpose, this will give you the most precise value. So it will give you the moisture, salinity, temperature from the single sensors. So it's a all-in-one package type of thing. Another is the hydroprobe soil sensors. So this one will give you the irrigation and soil monitoring, including the alert system that can be used for the alert system for the flood also. So for the paddy field it may be useful. And some environment sensors are also there, which will give you the environmental data that is live. If you don't want to rely on the meteorological department, that case you can put your own weather station in the paddy field itself. So this is one that is a compact weather station. Cost is $2,000. So it will give you the weather monitoring, speed, temperature systems, and meteorological station one that will give you the weather monitoring, authenticity checking, weather data gathered from the various source. And that is the weather monitoring, speed, temperature, humidity. So it depends upon your pocket and funding level, so what type of sensors you want to use. Another thing that earlier we told that pumping of water is not a very good solution in the tea garden. Rather on sprinkling the water will be the best solution. So there is uses of drone right now for the pesticide, for the tillage, and for the water sprinkling. So they are using these types of UAV. So this is another use of ICT also for the precision agricultural farming. So thank you for your patient hearing. If you have any questions, I am ready to answer.